All right, so for this one, your y is already by itself. So this is the one we're going to use right here. And we're going to take that and plug it in. And so when you do this, you're just going to rewrite this guy. Say 2x minus 8. And instead of y, we're going to write this entire thing. Negative 4x minus 9. And we still have to put the equals 4 here. So we are going to take this guy and we are going to distribute. So we're going to take the whole negative 8 there. And we're going to distribute that through. So leave the 2x alone. And then we're going to say negative 8 times negative 4. And that's positive 32. And don't forget your x. And then we have negative 8 times negative 9. And that's positive 72. And that equals 4. All right, so now we're just going to solve this guy. So you're going to combine your like terms, 2 and 32. That's 34 x's plus 72 equals 4. And then we are going to subtract that 72 over. Remember, if it crosses over, it changes signs. So we have 34x. Remember, when you're subtracting like this, you have a positive and a negative. You can say 72 minus 4, which gives us 68. And because the 72 was negative, we're going to say negative 68 there. And this is where we're going to divide. We're going to divide both sides by 34. So x equals negative 2. And once you know what x is, you can plug it back in. Y equals negative 4 times, instead of x, we'll write negative 2 plus 9. So negative 4 and negative 2 are positive 8. And that's minus 9, sorry. Minus 9, that equals negative 1. So y equals negative 1. So now that you know both of them, your answer is going to be negative 2, negative 1.
Wait, and then you did...
This is solving by substitution. So with substitution, you want to look for the easiest variable, right? So 3x is not easy because it has a 3 in front of it. 8y is not easy. It has an 8 in front of it. Negative 5x is not easy. It has a negative 5 in front of it. This is going to be your easy guy. So we're going to start with that equation. We are going to take the negative 5x plus y equals 9. And we want to get the y by itself, which means we want to move the 5x over, just like we did when we were graphing. You're technically adding 5x to both sides. That's why it changes signs when you move it over. So it's going to cancel out here, and I have just that y, which is what I'm looking for. And on the other side, because I moved it to the other side, it was a negative 5x. Now it's a positive 5x. The 9 I didn't do anything with, so leave him alone. He's just plus 9. Okay? And so I started with this equation because that was the one that was the easiest to get alone. So now I'm going to go to the other equation, this 3x plus 8y equals 14, the one I haven't done anything with. And that's the one I'm going to substitute. I'm going to take this group that I just got isolated here all by itself, and it equals y, right? We just said y equals that group.
Right.
So I'm going to take that group and put it into that other equation instead of y. We're going to substitute it in. So I am going to say 3x plus 8, but instead of y, I'm going to write that group, 5x plus 9, and that equals 14. So this is 3x plus 8y equals 14. Okay? And now I'm just going to solve. Distribute, combine your like terms, and solve. All right, so that's exactly what we're going to do. We're going to leave the 3x alone. Leave it alone, 3x. Take the positive 8 and distribute it. 8 times 5x, what's 8 times 5?
40.
So I have 40x. Then 8 times 9 gives me 72 equals 14. So I'm going to take this, and yes, we're going to combine our like terms, 3 and 40. Those are alike because they both have x's. The 72 does not have an x, so I cannot combine that, right? I need to subtract the 72 from both sides because I want to get it over there. It's going to cancel here.
Why?
43x, because I want to get the x by itself.
Oh,
So I'm
yeah.
going to move the guy that doesn't have an x,
Oh yeah, you already said this.
right? And remember 14 minus 72, you can say 72 minus 14, that's fine if you want to do this subtraction this way. And then this was a -9 right here, so this should have been a -9. So this is going to be a -72. I was wondering why I should be adding. I missed a negative, and this is why you check your work. If you get a decimal, check your work, because I'm not giving you decimals on this, all right? I was like, this should be 86. So yeah, this was a -9 here. This was a -9. This stayed a -9. This was a -9. So positive times negative, negative. So this is 86. And then when you divide, that's what I was looking for. Divide by 43. X equals 2. Yeah, if you get a decimal, check your work just like that.
So then you add 72?
Right, so then you add 72, right? You add 72.
84.
So this should be 86. 14 and 72 are 86. 4 and 2 is 6.
What was it at y equals?
So we don't know y yet, right? We just know x. We're going to go back here and plug it in. Y equals 5 times x, which we now know is 2, minus 9. So 5 times 2 is 10, minus 9, y equals 1. So my final answer here is x is 2, y is 1. That is my final answer. So for number 13, you have it kind of already set up for you a little bit. They're both actually by themselves. So we have y equals 6x minus 15, and we have y equals 4x minus 11. Both of the y's are actually by themselves. When this happens, just set the groups equal to each other. So set the first group, 6x minus 15, equal to the other group, 4x minus 11. And in this case, yes, we need to subtract our x's over because we need all of our x's on one side and we need all of our numbers on the other. And so I'm going to move this 4 over. And so that's when it's going to change signs. It will delete, it basically cancels itself out. And then on the other side, make it a negative 4x because it was positive. So here I'm subtracting x's. I have 6 x's and I'm subtracting 4 x's. So I have 2 x's left over. 6 minus 4.
Oh, yeah.
And then now that I did that, I need to move my 15 to the opposite side. So since I moved my x's to the left, I need to move my numbers to the right. And so it's a negative, so I need to do the opposite for the cancel itself. And because it was negative on the left-hand side, it's going to be positive on the right-hand side. So I have a negative 11 and a positive 15. Anytime you have a positive and negative, just subtract. Yeah, so do 15 minus 11, and that's 4. And your 15 was positive, so it's a positive 4. So I have 2x equals positive 4. And then divide.
Oh, okay.
Divide both sides by that 2. And so x is going to equal 2. And then I can go back to either of the equations and plug it in. So I can go back to this one if I want to. Y equals 4. And we know that x is 2. 4 times 2 minus 11. 4 times 2 is 8. 8 minus 11. Remember, you can subtract the other way. 11 minus 8. Right? And that's going to give us 3. But because my 11 was the negative, it's going to be negative 3. Y equals negative 3. 8 minus 11. And so now that I know my x and my y, I'm just going to write it. My x and my y is my answer. All right, so 26 is by elimination. So we're going to take 5x minus 2y equals negative 5. And we're going to say negative x minus y equals 1. Now, in this case, we want something to eliminate, and right now nothing will. If I were to add the 5x and the negative 1x, that would not cancel. If I were to add the negative 2y and the negative 1y, that would not cancel.
So we multiply it by a certain number?
Yes. So I'm going to take really the smallest one. This is negative 1. What would it cancel? Well, it would cancel with the negative 2 if it were a positive 2, right? That's the only way it would cancel. So I need to multiply negative 1 by what to get positive 2? What do I need to multiply by? Negative 2. So if I multiply negative 1 times negative 2, I will get positive 2, and that's what I want. So I need to multiply this entire thing right here by negative 2. Now, I'm not going to touch this first one at all right? He is going to stay exactly the same. So that one is going to say 5x minus 2y equals negative 5. That's going to stay identical to what it was. The second one, I'm going to multiply that negative 2 through. So negative 2 times negative 1, because that's what's here. Negative 2 times negative 1 gives me a positive 2x there. Negative 2 times negative 1 gives me a positive 2y there. And then negative 2 times this one way over here gives me a negative 2.
So how did we know?
At this point, we're just going to add. So we're going to add this down. 5 plus 2 gives me 7 x's. And you can see my negative 2y and my positive 2y cancel. Negative 5 and negative 2, remember you're just adding if they're the same sign. So negative 7, right? Divide by 7. X equals negative 1. Then go back. So like my second equation was negative x minus y equals 1. That was my original equation. So now that I know what x is, I'm going to plug it back in. Now pay attention to this one because it's a negative, negative 1. That means positive 1. Subtract your 1. Negative y equals 0. Technically, you divide by negative 1, but 0 divided by anything is just 0.
Wait, how did the y become a negative?
So once you have this, your answer is just going to be your negative 1, 0.
I'm scared I'm forget to plug it back in. That's what I'm scared of.
So your answer should always look like this, meaning you have an x and a y. X is first, y is second. So if you write your answers like that all the time, you'll realize you don't have a second number. And so you just plug it back in and solve for the second number.
And what is the difference between?
So when you have something like this, you want to get it in slope-intercept form first. So I'm just going to start with the first equation here. X minus 4y is greater than 28. Okay. The first thing I want to do is I want to move my x to the other side. So I'm going to keep that negative 4y there. So negative 4y. I'm going to keep my greater than sign. But if I move my x to the other side, remember it's going to be negative x. And I'm going to keep that 28, plus 28. Okay?
Is it negative 1x?
Yeah, and you don't have to put the 1 there, but we're about to do that. So if you want to put the negative 1 there just so you remember it, you can say negative 1x. And then remember I want the y completely by itself. So I need to get rid of that negative 4.
So plus 4, 2.
We're going to divide by 4. Divide by that negative 4. When it's just a group like that,
Oh, yeah.
just divide everything by negative 4 right there. So if we look at this one, the y is now by itself. I divided by a negative, so that's when you're going to flip that greater than less than sign. So that's going to flip from greater than to less than. I have negative 1 over negative 4. That's positive 1/4. And here I have positive 28 divided by negative 4. So that gives me a negative 7. So we can actually graph this guy here, all right? -7 is where we start, and we always start on my y-axis. That's this guy right here. So I'm going to go to -7 on my y-axis and put a dot. All right, -7. And then my slope tells me how to move. A positive slope is going to go either up and right or down and left. So positive slopes will go up and right or down and left. Okay, 2 positive movements, 2 negative movements. So you can go up and over 4, down and left 4. And you can see those are all on the same line. And then once you have it, you're going to connect them. And this is where you decide if it's solid or dashed based on that sign that you have. In this case, it's not or equal to. Because it's not or equal to, we're going to dash it. Yep. All right.
That's such a bad line.
Okay, and then we look at the greater than less than. My y is smaller than this line. Here's my y. Where is y smaller? Down here. My y is smaller down here.
So if you only look at it on the side.
And so if you always use this y value and say, okay, y is smaller. Right now y is -7. Where is y smaller than that? You're going to see that's down here. And that helps you when your slopes are really, really sharp slopes to figure out which way to do it. Because instead of being above and below the line, it's kind of like left or right of the line, and it's hard to tell. And it depends on if your slope is positive or negative. So always use that y-intercept where you started and see where is it above or below.
I see my mistake.
Let's look at my second one. My second one is 3x minus 2y is less than or equal to 4. So 3x minus 2y is less than or equal to 4. I'm going to do exactly the same process, all right? I'm going to move my x over. The -2y will stay the same. Less than or equal to will stay the same. Because I moved my 3x over, it becomes -3x. And that +4 stays the same.
How come we don't change the
So I'm going to take this. I'm going to divide everything by -2. This, and this by -2. I have my y completely by itself. I divide it by a negative. So that is when I'm going to flip-flop this guy right here. I'm going to flip it and make it greater than or equal to. I have a -3 and a -2. Negative and a negative. That becomes +3 over +2. And I still have my x. For the last piece, I have a +4 divided by a -2. That's going to be negative. One positive, one negative is -2. Yep. Yes, I'm going to start at -2, which is right here. I have a positive slope. So I can go up 3 and right 2, or down 3 and left 2. So I can go up 3, 1, 2, 3, and right 2, 1, 2. And you'll see where that is. It goes the same exact line, or I can go down 3 and left. The key is that your positive slope should always be going up from left to right. So if I'm looking at it left to right, like you read, a positive slope should be going up, and a negative slope should be going down. So this is a positive slope, so when I graph it, it should be going up, or I did something wrong. And then I decide, is it solid or dashed? So what is this one? Why? I have the little extra line, or equal to, right? Yep, so it's solid. So that's a solid line. And then I have to decide how I'm going to shade. It is greater than. So I'm going to look here, -2. Where do my numbers get bigger on this line? Yeah, right here. So I'm going to shade on this part of this line, right here. So for this one, I'm going to shade over here. There's this tiny little wedge where they cross over. This is the wedge where they cross over, down here. That's your answer, is that tiny wedge where they cross over.